Here now, a simple example of balancing a redox reaction with reinforcement of the steps that we just talked about. So we want to balance the following redox reaction. It's conducted under acidic conditions. And so we're going to be looking at iodine reacting with aluminum to produce iodide and aluminum +3. And this is done under acidic conditions. So we could start with step 1, which is, right, we have to assign our oxidation numbers, right? We want to determine what is being reduced and, what is being oxidized. So if we go up to the reaction and start to assign oxidation numbers, we would have a 0 for the iodine starting material as well as the aluminum starting material. The iodide on the product side, monoatomic and has that -1 charge, would have a -1 oxidation number. The aluminum, similar, it's monoatomic, has a +3 charge, so it has a +3 oxidation number. So that means our iodine element is being reduced. It's going from that 0 oxidation number to that -1, and that's a gain of electrons. And our aluminum is being oxidized. And that's because we're now going from a 0 state to a +3 state, and that is a loss of electrons. So that's the first step, assigning oxidation numbers. Step number 2 is to develop the half reactions. And so we have our half reaction for reduction, and that's just looking at the iodine going to produce iodide. Again, reinforcing what we see above, starting from that 0 state, going to that -1 state, right? This is a reduction or a gain of electrons. So there's our half reaction for the reduction. And then we also have our half reaction for the oxidation. And so here we're looking at the aluminum going to aluminum +3. Oxidation number being 0 for aluminum solid, +3 for the charged aluminum, and that is an oxidation or loss of electrons. So here is where we balance each half reaction individually, right? And that's our idea of steps 2A through to E. So I'm going to start with the half reaction for reduction. So we have our iodine going to our iodide. And so for step 2A, right, we want to balance out elements other than hydrogen and oxygen. So that's really looking at the iodine. So our half reaction would develop a little bit further to show that we would be having 2 of those iodides being produced because of that balancing of elements. 2B, we balance out oxygen by adding H2O. In this case, there's no oxygen, so we can go to step 2C. 2C, we want to balance out hydrogen by adding H+. Again, similarly, there's no hydrogen, so we can go to step 2D. Step 2D, we are under acidic conditions, so we skip 2D. We only use 2D if basic. And so that takes us to now to E, which is to balance charge with or by adding electrons. And so if we look at the reaction where we're at here for this half reaction, here is where we are. We have the iodine making 2 of the iodides. If we look at charge, charge over on the left of the starting material is 0 because this is neutral. There is no charge on any of the starting materials. We'll only one starting material, iodine. On the product side, our charge is equal to -2 because we have 2 iodines that are -1 in charge. So we need to add electrons in order to balance that out. So if I add 2 electrons to the starting material side, remember this is a reduction, now I find my charge is actually the same. So now I have a charge on the left equal to -2. I also have a charge on the right, which is also equal to -2. And so here is my balanced half reaction for reduction, where I have 2 electrons plus my iodine produces 2 iodides. So that was the balancing of the half reaction for reduction. We now have to do all those steps again for the half reaction for oxidation. So now we need to look at the half reaction for oxidation. And so with that half reaction for oxidation, right, we were looking at the aluminum. And so if we look at our steps, 2A, right, balance elements other than hydrogen and oxygen. All right, so this is already balanced with the aluminum, so we don't have to worry about that. With 2B, right, we balance oxygen with H2O. Right, no oxygen. So we go to the next step. Step 2C, balance hydrogen with H plus. No hydrogen, so we can go to step 2D. And again, with 2D, only we're under acidic conditions. So we can skip to 2E. Right, this step is only used for the basic conditions. So then we go to our 2E step. And so we want to balance our charge by adding electrons. So if we look at our reaction, we haven't really done anything since the beginning with this half reaction. All right, so we're still left at this state. And if we look at charge, we have a charge equal to 0, right? Because we are neutral on the starting material side, and we have a charge equal to +3 for our product side because of the aluminum +3 charge that we have there. And so that means that we need to basically balance out this process by adding electrons to that product side. So our reaction turns into aluminum, produces aluminum in the +3 charge state, plus now 3 electrons. And so now we find that our charge on the on the starting material side on the left is equal to 0. If we look on our product side, we also find that our charge is equal to 0, +3 from the aluminum, -3 from the 3 electrons. Each one's -1 charge. So that gives us a 0 state. And so there is our balanced half reaction for oxidation. So we're looking at our aluminum producing aluminum that is in the +3 ionic state, as well as producing 3 electrons. So now that we have each reaction done, so now that each half reaction is balanced, we want to proceed to step 3. And so for step 3, we want to now combine the half reactions, again making sure the number of electrons in reduction equals the number of electrons in oxidation. And I was saying earlier, this normally means a cross multiplication type feature. So let's write our reactions down again. So we have our reduction, which is looking at the 2 electrons plus the iodine produces iodide that is aqueous. So there is our reduction. And then for our oxidation, we are going to look at the aluminum. So if I rewrite that process, we would have our aluminum going to produce aluminum in the +3 plus our 3 electrons. So here's where we're going to cross multiply by that number of electrons. That I want the number of electrons to be equal to one another. So I'm going to multiply the reduction by 3 and the oxidation by 2. And so this basically sets the stage, for the electrons to be equal to one another. So that's the cross multiplication feature that I was talking about. And we can sum these reactions up. And so we end up with 6 electrons plus 3 iodine, that's our top reaction, plus 2 aluminums produces 6 iodides, 2 aluminums that are +3, and 6 electrons. And so there is our balanced process. It's not simplified yet, but it is actually balanced. So now that we have everything combined, we need to simplify the redundancies. And if we look at the redundancies, we can see those in terms of things that we find on both sides. So our 6 electrons would go to 0 because we also have 6 electrons on the right side. So those both drop out. And then that's it. And so we're left with this as our overall redox reaction. And so that should be our process. We should be done. You can always do, as a final check, you can also make sure charge is equal still on both sides. So if we go back to that charge idea, we see that we have a charge equal to 0 on the starting material side. None of those molecules are charged. None of those elements are charged. If we look on the product side, we also have a charge equal to 0. We have 6 iodines, so -6. We have 2 aluminums that are +3, so +6. And so they cancel out to give us 0. And so our balanced redox reaction is finally this process. 3 iodine plus 2 aluminum produces 2 iodides and 2 aluminums. That is both in the +3 state. And that is our balanced overall redox reaction for this example. And like I said, this is one of the easier ones. So again, I know a lot of text here, a lot of steps within this method. Did a somewhat of a simple example, and I realized that this is not enough, that we need to do more examples of this redox balancing. So look for more examples, a little bit tougher examples in the upcoming lectures. Look for those soon.